The reason for studying this piece is based on its multifunctionality, because with a simple design it is focused on supporting all kinds of efforts. We can also see it in multiple places in our environment. It is enough to look a little. The selected dimensions were made arbitrarily, keeping the proportions already given in the PDF. In the following table we can observe the variation in the radii of the holes, where the first data is the hole on the left, the second is the hole on the right, and the third is the one in the middle, and in the same order the percentage difference with the original. Below you can see the model piece in ANSI, its mesh, the load, and its point of application. The selected load is 10,000 newtons. This is due to the fact that when it varies with different loads, this is the one that presents deformations. With lower loads, it does not present observable or significant deformations. In addition, its location is due to the fact that it is here where what can be placed. You want to support. The other holes function as anchors to some surface. Next, the piece will be presented in 3 different materials where its hole geometries were varied, being the first in the table the left hole, then the right, and finally the central one where the load is applied. With the help of the program I search for geometries with which maximize the safety factor and reduce the maximum effort. In the images we can observe a color change. This is where we find the concentration of effort, and to know when this is, we can guide ourselves with the table and the color bar on the left that tells us its intensity. In the 3 materials we find that the piece with the best response to stress is the first. This is due to the fact that it presents a higher safety factor in all 3 cases. It can also be seen that the larger the holes, the more effort is supported and the less the safety factor, this especially in the hole in the middle, which makes sense. The larger it is, the smaller the area that presents the concentration of efforts. It is recommended to select geometry number 1. With respect to materials, if you want to save money you must choose aluminum because it is the cheapest but it is the least resistant. If costs are not a problem, titanium is superior, having up to 4 times a greater safety factor compared to steel. We select steel because it presents us with a balance in costs and benefits.